to this new episode. And in this episode, we are speaking of why agents need TEE for privacy and security. And we have the best people in the space and in this room right now who can answer this. We have Gavin from 10 Protocol, and we have Marco from Oasis, and we have Prashant from Spheron. So this episode is going to be very special because there is a whole wave around TEs, and the narrative really picked up when there was GPUs and people were speaking about it, and everybody said we need this right now. And we have been in conversation with multiple infrastructure where TEs has become a specific use case. They are building on top of it, and there are so many agents which have utilized it just in their documentation. So we want to understand, like, from everybody in this room, like, because there are two people specifically who are very much big, like especially 10 and Oasis have been flag bearing this TEE wave really amazingly. And Prashant, we have been doing, like, I'm speaking of Spheron, not TEs. So thesis and antithesis of TEs. Like, what do you guys really think is, like, on day zero, if anybody has started creating AI agents, what do you think is the possible use case of TEs in that? Like, if somebody has got started and has started watching this, like, yes or no? And anybody can jump in on this. Like, this is not a.
So was the question whether there's a use case with AI and TEE?
Yeah, from day zero.
Oh, completely. I mean, it's been proven already, right? I think, Marco, you've probably seen this. Prashant, you've seen this, I'm sure. Where, how long ago was it? Like, I think it's before Christmas. You know, we had these autonomous AI agents running within a TEE, and for the first time, you could demonstrate that you could have a genuinely individually empowered AI agent that wasn't going to be meddled with by human beings. You know, so you had absolute certainty that you had this AI doing this AI thing. I think that's pretty cool. What do you think, Marco?
100%. I mean, I still think TEs are the most practical solution for the things that they offer, meaning verifiability and privacy. Like, you don't have to care about privacy, but generally you should care about verifiability, specifically in the crypto space. I mean, this was the first thing that really bothered me once we started talking about decentralized AI. And I know, Prakash, you said not to be philosophical, but this is just like, this is what crypto was built on. It was built on decentralization and verifiability. And now we're using these AI models, these LLMs, and suddenly we're just accepting their results into the deterministic blockchain world, and we kind of forgot about verifiability. And that's definitely one of the flags that the whole TE community was bearing and waving, like, hey, we need verifiability for all of this AI compute.
Yeah, because wasn't there?
Yeah,
sorry,
and I think quite right. Quite rightly put, Marco. I think there are. I'll just add a few things because it was very interesting what Marco just said. Was around, like, there are a lot of things which we forgot in Web3, and I'll come on to that, like, down the line. Just this line itself. But yeah,
you're right.
Go ahead, Kevin.
A load of things have been eroded over the years, without a shadow of a doubt. What was the point I was going to make? You know, there wasn't an AI agent where it was tweeting. I can't remember the name, but it was tweeting, and then it came out that actually it was somebody in the background was kind of actually doing the typing.
I think it was like there were certain things around, I think, AI XPT and
yes,
I think.
But you got to start somewhere, right?
Yeah, I think that's one of the extent, right? Another extent is the builders.ai. If you guys have ever seen that company going down to see. So they have basically used, like, raised billions of dollars just to, like, where people will gonna be like, or like AI will code it. But eventually what was happening, like, they have hired a lot of engineers in India and a couple of other places. What they were doing is that whenever you were submitting the request, they were just basically coding on your behalf, right? So it's like, I think that the fundamental theory of verifiability just gone lost. Like people don't really understand it at the very, and that's the reason we wanted to have this space where we can have more straightforward understanding about T's, what are the things which can be involved. And by the way, I also have a very good interest into T. The reason being because I have spent quite a good amount of time in privacy space before even jumping into Web3. I was working with Siemens, worked with their data center, like a lot of healthcare data, and moved around those systems. So, and I'm going to come on to that angle as well. So there are two angles for now, which we are going to be like, I'm just noting it down just for you guys also to keep prepping. After Prakash is over with his question, I'll jump into that. But yeah, I think rightly pointed given, like verifiability and all of those things is like insane. Like people are not that cautious.
But do you think, like in terms of builder's journey, at what extent TEs are coming into play? Because pricing is something which really plays a role. Because we know it, like as a provider, once we go out and we give out bare metal machines, there are requirements for TE specific machines as well. So you think that there is bloated pricing towards TEs, and once people get that, like they initially, like teams start utilizing it, they have to be very specific. Their whole structure of their product should be very much around privacy and certain limits of making sure that user data and even company data is not hampered with. So once they are not on that scale, do you think, like, coming back to the same thing, like if your thesis is not in that direction, do you think TEs would make sense? Or if you're just a builder who's trying out something in the privacy segment, do you think you should jump onto bare metals first, or something which is much cheaper, because they come at a price, honestly? And in crypto, we have seen that, okay, 1 is equals to 3, because even in funding and even in ratioing with anything, like everything has become a specific ratio of higher price. Like if you go out and hire a photographer even in Web3, it becomes 3x the price, and they start speaking in dollars. I don't know why it happens, but yeah, but like you understand, like from that perspective, when I think about it, like, okay, there are a bunch of college kids who just started a project and they are doing privacy, and they're saying we are doing recently we saw somebody on the stream as well. They were doing a specific private transaction with agents, and they specifically on their white paper, it's written that they're going to use TEs, but in the reality they are using AWS instead, and which is not TEs. So where does this business proposition jumps in? Like,
I mean, that's a tough one. TEs versus centralized offerings like Nitro Enclaves. I mean, that's a whole box. Unfortunately, most people just accept that it's TEs, and they're like, hey, this is secure enclave. I can run my application inside. It kind of has some properties of real TEs if you want. And for most, it will be fine. Like, even if you check like most of the key management systems out there today, they just use like 2 out of 2 or 1 out of 1 signing, like the whole Coinbase developer kit. They use these wallets, and those keys are actually stored on AWS servers, and it is definitely possible to extract those. So I think at some point it really depends on the founders and builders, if they really care, what's kind of their security metric, like how decentralized does it need to be, how secure does it need to be. And I mean, if this is really part of your value proposition, then you should care. If you're trying to currently build like a private GPT, I think it's fine if you just start with AWS Nitro Enclaves, and you kind of slowly move towards more sophisticated TEs. But the reality is most people currently do not care. Like, I have so many discussions with projects that are like, hey, yes, we're using TEs. And then I kind of check the whole docs and architecture, and it's just like, wait, but you're using like very centralized providers. You don't control even the bare metal machines. You have very little access to reproduce things. So it's a tough one, and it does become a bit idealistic again. Like, and sorry for the longer rant, but one of our most known projects that's building with us is Ocean Protocol. And the main reason Trent McConaughey, the founder, decided to build with us is because he's a decentralization maxi. So he was like, hey, I really want to use on-chain privacy. I really want it to be as decentralized as possible. That's why I went with Oasis. He could have done this in a more centralized manner. He could have actually done this in an off-chain manner, and people wouldn't have cared. Like, the users would still use the application. So it was really driven by him and his kind of interest in being as decentralized as possible.
Yeah, you're right. There is a spectrum, isn't there? And often the spectrum is kind of cost-based as well. Like, you could, to answer your question, about whether a one-man builder could get started, he could probably buy a Dell machine off eBay with a Xeon processor from like 2005, and that will give him Intel SGX straight away, and he can start mucking about with that. They can start mucking about with that. And obviously the bare metal is an option, but to Marco's point, you've got a whole ton of TEE enabled infrastructure like Web3 infrastructure providers, Web3 projects. So actually, as a builder, you don't necessarily have to be TEE aware, because you're just going to deploy your Solidity smart contract. You're just going to use your remix to deploy to a privacy provider, and they will have in the background the TEE already baked in. So I think we're actually getting to the point where your average builder, unless they're particularly interested in learning about TEE, then they could just go to one of the many Web3 providers like Oasis or 10.
And if the question is, should they do it from scratch? They really should not. I mean, TEs are not fun to mess around with. Things that can be done wrong. And I mean, we see even projects that have been working with them for many, many years, they kind of get exposed in some recent research papers, etc., because it's just, there's so many things you have to consider to make this right. Like, I'm super glad I don't have to mess with the actual hardware things, and it's a way smarter team than I am, because it's honestly a very different beast than software development.
Depends on your definition of fun, Marco. I do know some people that get a kick out of working with TEEs.
Yeah,
it's an acquired taste.
Guys, I just wanted to like, I also just wanted to like come on few things which is very important to kind of learn more from the builder's perspective, like how, because like I'll get started with this one. If T is so much exciting, and let's be very, very honest on the answers on both the side. If these has been so much, like it's so much of a great tech, I would say, then why I think T was around for quite a long time. I think it has been quite a long time, and Intel has been like investing into heavily for a very earlier days. But when I was, and very genuine question I'm asking this, when we look around the T use cases, cloud come in, they basically provide you some data privacy and anything like that, which again, it's a cloud, so by definition they are public clouds, so by definition you are agreeing their terms and conditions. So essentially, if you are using their T's or whatever, they know what you do. Like I think they have certain layers, and they haven't open source any tech, so you don't even know what is happening in that black box. But since they are compliant, like, and that's how the world works. Compliance in any system just works better than better than any tech out there. Like if I'm very compliant system, that the other companies or people like who are into this space, they'll be more than happy to use a compliant system versus non-compliant one. And my question revolves around the same. When we look at decentralized systems, like very few decentralized systems, I don't know like if you guys have got compliant or not, but I was looking into 10 and Marco in the Oasis, I haven't seen that, but if any layer on top of you guys have been compliant, that's a different thing. You can bring that in. But if you look at decentralized system, which is very tricky to get compliant certificate as well, because it's very different, right? Because we are also building infra solution, and we know like we have to have go and build a service layer to ensure that we get some compliances. How you guys are looking at important when it should option for T's over a decentralized network? Because I'm not going to trust a random T providers into the space to just right or believe in the tech, because I don't know the tech. Like a lot of people don't even know the tech. Like they don't even know what happens when you swap a token from A to B, right? They just swap it. So now the question, again, summary is that how do you guys, or how are you guys looking to tackle these problem for the adoption in decentralized system?
So when you talk about compliance, what particularly are you what kind of compliance are you talking about?
Let me tell you this. So let's say if I'm a hospital,
okay,
right? I need to have a HIPAA compliance done, or I want to work with GDPR compliance to be like there, or I need to have an SOC2, which is at least the handling the infrastructure properly and everything, compliance security policies are all in place. I want to know, like in the ISO 2000 or something, whatever compliance which is out there is already in place to ensure that whenever I send a request from one place to another place, all be encrypted, properly done, properly transmitted without an exception in between, or there's a one layer in between of your interface and my interface where HTTPS gets cancelled out, and you can basically let's read that entire certificate utilizing it, right? So there are a lot of these things can be easily exploited on any systems, and that's where compliance comes into the picture, right? To ensure that if something goes wrong or something goes right, or they come in, third party auditor come in, they look into that, right? So that's what I'm kind of like asking that.
Yeah. Okay. So I guess I'm going to put a bit of a Web 2 hat on, because I guess that's where I've come from. But from my perspective, I think it ends up leaning quite heavily on the compliance capabilities of the providers that you're using. So I think for the example that you provide, Prashant, it's like you'd want to make sure that every layer of the technology has a degree of compliance reassurance, depending upon your own compliance criteria. Because obviously you as a company have a responsibility to define what you think compliance looks like, and you would typically lean into the laws of your jurisdiction to determine what that compliance needs to look like. And then you're marrying off what you want with the providers that you're giving you. And I guess this kind of chimes a little bit with what we were just saying about centralization, is that you end up having to lean into compliance legislation that isn't necessarily of your own design, particularly if you are using a third party. But it doesn't stop you being decentralized. You can still disseminate the operation of the technology or the solution across multiple decentralized players, but still use a technology stack that you recognize as compliant. Be interested to hear what Marco says there.
I had this discussion actually with our founder not too long ago, because we're kind of building a dashboard where you can see all the deployed TE applications, and we're like, how many green check marks do we need to put so that people kind of trust it? And it's kind of compliance, right? You see a green check mark, you're like, okay, wait, this is compliant. And he was like, it's like HTTPS, like who actually checks the certificates? I'm sure no one does. And that's the beauty of open source, in my opinion. Like everyone can inspect the source code and see that what we are doing is correct. And not just you can check it, but actually that's the kind of job of the whole network. Like we have built a blockchain, like all the nodes, they constantly verify that everything is happening according to the rules kind of set. So I don't know. I don't think too much about compliance per se. I don't know, like, is Ethereum compliant? It's definitely more a job for the applications building with us, especially if it is privacy related applications. Then they need to be more wary of compliance, how to be like, how do you build a privacy pool that's actually compliant? We will support them with the tech, with the infra, but we kind of leave the burden with them to make it compliant, if it makes sense.
Got it. I think, yeah, but there is one thing which I just wanted to emphasize on. Let's say I know you guys are like talking more on the front of what if the provider who is providing the compute is already tier 2, like tier 4 or tier 5 data centers, and they're already compliant as per their own jurisdiction. So basically what we do is like we just channel it back to our users, the same compliance system, right? Because then you don't own the compliance as such, right? That's basically how it looks like. But what if in a decentralized network, right? So what if providers are not these data centers?
But isn't that the beauty of TEs? I mean, that's exactly why we work with TEs. Like they provide you cryptographic attestations, remote attestations that verify compute integrity. Like specifically also TDX machines, they have like multiple measurements that make up the identity, and you can verify those. You can measure them. You can kind of recreate the binaries of the app that is supposed to be running in the machine, and you can kind of compare those and reproduce the build. So it really, that's for me the beauty of this, because it doesn't matter if it's a data center that is officially compliant or user at home with his Xeon 6 CPU, they can all participate and provide this service. And the users do not have to trust them, because that's what the network does. The network verifies the attestations, it verifies the measurements, and anyone can reproduce builds and see like, hey, the binaries are the same. No one is messing with the app.
Amazing. I think then it basically solves the problem. Is like there is no modification in the code, so there is no
Exactly.
modification in the output. I think that should be that should be the system. Is like unless there is no modification in the code, there is no modification in the output.
No, exactly. That's it. Like on one hand, you have the remote attestations that give you the compute integrity, like the machine hasn't been messed with. And then you have reproducible builds that kind of give you some guarantees like, hey, at least the binaries are the same. This application is still running in this TE. It wasn't upgraded or changed because it would impact the identity of the machine and the app.
All right. So I think then it's sorted. So essentially, we don't really need a high level compliances unless you are not building a service layer on top of it. On the hardware, it's fine because ultimately it's all encrypted and remote attested. Now, following on this one, the second question which comes into the picture, which any builder, like again, it's this question because that's what any CTOs and like they will be thinking about while adopting any of these. Okay? Which I would ask from you guys is very simple: is that what happens when I adopt TEs? Example: do I need to go ahead and write a different set of code for TE, or it's the same set of code which I can just go and deploy as it is? That's one thing. Second thing, since TEs are being supported by certain members in the hardware space, and all of these TEs are, of course, they are like they come with different parameters and mechanism and everything. How does it changes from Intel Enclave to, let's say, to AMD based systems which they provide? Would the same code will run on both of the same machines, or do I need to have a different? Basically, what I'm trying to understand is the concept of vendor lock-in. Am I going to get vendor locked in if I opt in for TEs?
So, yeah, I'm slightly out of my depth here, but I guess because I don't know the level of coding down to be actual per TEE, but I just want to reiterate that a lot of work has gone into abstracting away from the TEE provider. So really, you just, as a developer, you just keep writing in Solidity or whatever language you want to use. You shouldn't have to know about the TEE, and I think that's the right end state to get to. You know, we don't want people to have to worry about which TEE they're running on. They leave that to the infrastructure provider to make the best choice. But Marco, you might be aware of some differences. I don't know how I would strongly suspect if you were writing for an Intel TEE, it would be different to an AMD TEE, for example.
I mean, if you're impacting the bare metal, sure, the BIOS, but the cool part is for builders, it does not matter. So on one hand, I mean, there's multiple things, right? So currently we have our own chain, S10 does. It's Intel SGX based. So that's the kind of confidential EVM with on-chain privacy that we've had in production for more than 2 years. And it's as Gavin said, you mainly need to know Solidity, and then you need to know some unique things regarding the chain that are maybe not possible because state is encrypted, etc. Like you cannot impersonate accounts to check contract state. It would kind of break all the privacy. Then the second part is TDX. That's kind of the latest, and it's not even that new TE environment that everyone's playing around with. Why? Because it's actually really unique for builders. You can spin up confidential VMs. So since it is VMs, you can just treat it as a TE cloud, and you can host any arbitrary application inside. So for example, specifically for builders that want to deploy their, let's say, agents in our TE cloud because they want these trustless guarantees, and preferably they also want to utilize some decentralized key management system, they would just need to Dockerize the application. And then with our CLI, currently we're working on a no-code solution, but I mean, I think most are familiar with CLIs. They would just build this TE app and then deploy it in our cloud. There's like a YAML file that shows all the images that go into it. There's a .org file, and that's the one that's actually being hosted. And then you have access to lots of tooling like key management, secret storage, etc. And then you can, for example, store credentials that your agent needs. This can be API keys or just kind of any credentials to log into different applications, and you store them on chain. And on chain, you also have these policies that govern, like, hey, who can upgrade this agent contract? What can the agent do? You can set some specific criteria, and you can pass those secrets to the agent. The agent is living in a TE, so it's always passed encrypted. In the TE, decrypted, the agent does something and it's encrypted again. And likewise, you can derive private or key pairs. It doesn't matter it does matter which elliptic curve, but we have support for multiple. And then you can use those keys for signing messages on all kinds of chains. That's the coolest part, if you ask me, about TEs, because TEs by default are off-chain. Like, they can do things the off-chain route. Like, you don't have to go back to our chain, Sapphire, and then use like router protocol or something to pass messages. You could just go the off-chain route and just do like RPC calls or something and impact the chain directly. So multiple values on what builders need to know. But my short answer would be, you do not need to know about TEs. You do not need to adapt to like specific Intel or AMD. What you do need to adapt is some specifications, like in our chain case, either the on-chain privacy, there is some kind of uniqueness about it, or, hey, we have our own framework for these applications. We think decentralized key management is very important. That's why we have it as default. So you kind of need to adjust a bit to this. But your agent code would stay the same.
Yeah, I would need to just little bit cross-validate on this statement, Marco, on the same usage of the code on different machines. Because I'll tell you how, and the reason I'm saying this is because architecturally both the machines are very different. They are not same chips. They are different chips. And when we look at the encryption and decryption and all this mechanism, they all work very different in a different bit environment, right, into their own systems. So I would need to check this, because last time when I was around TEs, it was that you get vendor locked in the moment you do that. The reason being because it's Intel wanted to, the whole idea of the Intel initially was, I don't know like what they're doing now, but whole idea when it all started, it was that if we build this, there will be more vendor lock-in system which will get built and will make more money out of it, right? That was the whole like, and then all of these concept of all of the things system which basically come into the picture, which again I just dropped you, by the way, a link which you guys should definitely take a look. It's called GremlineProject.io. And we have been around this because and there are a couple of more who have like, they have built a language which basically it's an interpreter essentially. It converts your whatever code in the T whatever, and it basically makes your T more code more interoperable in both the systems. So they build their own interpreter which basically like runs the code in different machines without you changing it. But yeah, I think that.
Yeah, there's of course big differences. I'm just saying, like, developers that go to us, they do not have to. Like, you are an agent builder, you do not need to worry, as Gavin said also with Tan, you do not need to care about the TE stuff. Like, you would host or build your application as you would for AWS, GCP, etc., and you just host it in the TE cloud. And then during the build and deploy process of the actual TE app, you would need to kind of know some specifics about the platform you're interacting with. We are currently very much focused on Intel, just because in our opinion, it's the most sophisticated one and it works the best, even though it still does not work very great. They sometimes change some attestation certificates and suddenly stuff breaks, which is ridiculous that you don't get notice period before, but it still happens, and we are kind of dependent on them to do a good job. But we could switch or include also AMD, SCV, SNP, etc. And honestly, we really do want to, because it would provide some more defensive depth into the whole network. It's just, in our opinion, they are not on par, and that's why we focus on Intel TDX. And we have done
I think you just brought in my next question, which I was about to ask. And you just spoke about it now. So essentially, if you look at the TEs, right? So TEs works. So it's a key, but the key which is baked into the hardware, right? That's how, let's say, just for anyone to kind of like understand on a very high level, like this is how it works. So it's a key. Somebody has to have a key. Any encryption should have a key. Without keys, there is no encryption. Like, I don't know like which kind of method, I don't like mathematically we can build something which has some random values generated and then somebody else, but there should be key, right, which is involved as a padding or anything like that. And that's how security, like all the system has evolved over the year. Now coming back to the part of the attestation which you have rightly mentioned, is that Intel is the centerpiece of this entire dance, like this entire game, right? And Intel owns the key. When I say the key, it is just a thing which can screw up your entire hardware and systems down the line. Let's say tomorrow, if they decide to go ahead and say, let's say, hey, you know what, T's are not working out for us, and we are just making like we are just going to kill it, or we are just going to do something like that. It's highly dependent on one company defining the fate of a lot of decentralized systems out there. That's one. Again, this is purely imaginary, which is not going to be happening. Like Intel is not going to shut down T, because there is already more than $10 billion market which has been already been created, and it's growing year on year. Like 2023 data is like around $10 billion. They have like done a business around the T systems. And it's growing aggressively. Right? It's every day and every hour. And now H100, H200, all of these machines also. NVIDIA also introduced T by default into the GPUs. So it's a good signal for all of us, like to kind of like go ahead and get into that. But the question remains the same thing, right? Like we took the example of Ethereum when we said that, are we gonna validate if Ethereum has been like there or not? Like there's a validator system which basically validates that. Here we don't have any such kind of control, right? Like what you just mentioned, they may change the keys, then you don't have a timeline to fix, but it does kills the user experience. That's one thing. How you guys are envisioning or trying to solve this problem? I know this problem is like not solvable at this point of time, but there are ways to overcome it. I would love to hear that out.
I can go again. As I said, we are keeping it very flexible. So if there is a different provider that provides an experience on par, like from security and developer experience, we would love to include it. It would definitely be work to be done by us. So we would need to be able to kind of accept the remote attestations in our network, provide the environment. It would be a lot of work, but we would definitely love to. Currently, we are very much Intel focused. There is already tons of defense in depth mechanisms in place. There are ephemeral keys. We use MPC protocols for threshold encryption. We have a separate key management committee that distributes decryption keys. So there is already all of this in place to keep security as high as possible. Like even if you would have one compromised node, like not speaking about an Intel backdoor, but just like I don't know, some electron microscope reading the private key that is actually on the hardware. Don't quote me on that. As I said, I try to stay away from the hardware security parts, but there is already lots of thought being put into it. What happens if you have a compromised node? And I mean, it's also quite a bit of game theory, I guess, because you would need numerous nodes to be compromised at the same time. They would have to be picked during the same epoch to then be able to decrypt some things. They would still not be able to post false states, etc. So a long answer to say that we are trying to be flexible, but yes, currently there is a massive Intel dependency.
Yeah, you're right, Marco. You can definitely do a lot with robust governance, and I think you're right. I think provided you've got one node within all the network that's still provably unmolested, for want of a better word, then you're still in a safe position in that you can, you might have to stop the network temporarily, but I think fundamentally you wouldn't lose funds, but you might just have to pause to be able to address what's happening. And I think I think it's early. Well, it's not early days. I mean, to your point, Intel are huge. They're never going to put their business at risk by doing something stupid. And I know human error comes into play, but with enough diversity, even just across your nodes all running the same Intel hardware, you can still do enough separation between those nodes to give you the comfort that you need to be able to run the network. So yeah, it's a fair point, but to be honest, it's not our highest risk on our risk register. I must confess that we've got vendor locking.
Yeah, I think there's a risk, and the risk is the Intel, and and that risk is like a very, very, like, if I had to design my solution, honestly, like I would always look into this risk, because that's how, like, you, whenever you build an entity or you build any systems, you have to basically have a rollover systems and everything. And I think what Marco and Gavin, both of you have just told, it's quite interesting, because what if you guys can have a rollover of AMD systems, or let's say some other systems, then it just solves the problem, because then we have a rollover system, like, so fallback systems, what I would say, like, now if something fails on Intel side, I can immediately fall back to the system, which is again it's like you have to basically create a more problem for AMD also, then it goes back into the row. But again, I think, thank you so much for, I have a final question before I hand it over again to Prakash. And again, the whole understanding what I'm trying to make here is for everyone. Okay. And if you guys feel like the question which I'm asking is not good, you should just tell me. Like, here you can just send me on private chat. But understand is the use case perspective, okay, which is very important. When we talk about agents, like what you guys have mentioned so far, is that they are playing around keys, right? And there are better solution in Web2 world where you can solve the problem of key management, which is called KMS, right? Which are key management solution and key management systems, which exist in Web2 at scale. If I'm not, did I lost my internet?
We hear you, but it's a bit laggy.
Okay. But we got the point. I think he's saying KMS, yeah.
So I was talking about the key management services. So if it is all about managing the keys, why I should not use KMSs to manage systems, and why I should then choose T? Like, why we should use T? But I'm just trying to learn from you guys, because that's very important. Because if whatever I say here, nobody is going to believe me, because I'm not a T guy. But I would love to learn from
He's an ex-T guy, so it's a toxic relationship with T.
I love
not so not a disgruntled ex-TEE. I think Mark has touched on it already, you know, by saying I think TEE is a far more complete solution, and I think the attestation component is super relevant here, because you want to be able to know that the code that you think is running is actually running. I think if you're just using key management services, then I don't think that's helping you prove that your code is correct and hasn't been meddled with. It feels like it's two different things.
It can be proved, and we can design a solution. It can be proved, like the code is running even without T's, because there were systems which we have, like there was system which has already been built in Web2s. And I'll tell you the reason why I'm saying this is whenever you design a hardware, like any solution for healthcare systems, whenever you install a binary of a system, it basically, that binary has to have the same SHA-5 like core encoding generates whenever you install on your local machine. Okay, if it is different, then that's how we used to validate and verify, even though it is not TE, we used to verify that if it is the same thing or not. In decentralized system, it becomes more complicated, but in Web2 system, it does exist. Like how you validate if the same software is currently running or not. That still exists. But just wanted to understand that KMS part of that, because if the whole core focus of, yeah, Marco, please.
I think the topics are a bit orthogonal. Like you pick KMS and TEs for different things. I was just pitching it before as a very cool combination. So most of the agent projects, like now I was talking specifically about all the agents that talk to me, they come to me on one hand for trusted execution. Like, hey, like we discussed before, I want to kind of guarantee to my users, I'm not the one putting out the output. This is actually the application, because it's running in T. I don't have access to actually do the things that the app is supposed to be doing. Yes, this can be even stuff like Twitter accounts. I honestly do not care about it, since the Twitter account can't do that much damage. But when we're talking about user funds, then you really want to make sure that whatever the agent is doing, whenever it's doing transactions, etc., that this is the actually happening via the code. But the KMS comes into play when talking about these wallets. Like every agent that wants to provide some utility, they will be wanting to have a wallet. The wallet is on one hand, of course, just for transactions, for payments, for paying services, for receiving payments, but also the reputation of the agent. The thing is, it's really not that trivial to give an agent a key, because whenever you create it somewhere outside, you have had access at some point to the private key. So that's where TEs plus a decentralized key management are very cool. Like what I mentioned initially, like in our case, you can have your TE instance for your application, and you can have access to the key management system that we've been working on for the past 7 years, because it's an integral part of our consensus layer and the EVM. And then you can derive key pairs on different elliptic curves within the TE. The agent can then sign on all kinds of chains, and you as a developer can, at least on some level, guarantee to your users, I have not had access to the private key. I'm saying on some level, because everything can be extracted by code. That's why the reproducible build that we talked about initially is so important. Like just hosting something in a TE doesn't solve almost anything. Like you could still have access to all the credentials, you could still have access to the funds, you could still be faking output. You really still need to have open source code. You need to have some way to verify policies, someone needs to check the attestations. It's really a whole system that goes into it. But I think TEs plus decentralized key management are a very attractive solution for most. Like really, I think like half of my calls this week with agent projects so far has always been about the key management. They're like, hey, and at least like in my perspective, like if we look at the agent space, I think we're past the fun agents. Everyone is trying to build like really useful agents. And I think one of the reasons why we're still lacking adoption is trust. Like everyone in crypto is a hurt child. Like we've all been scammed at some point, drugged at some kind of raise or whatever. And even if a very reputable project is launching their agent, even I am quite hesitant to just now like deploy 10K USDC into it, even though they promise like 20% API. I did, for example, APY.
20% is by the way, 20% is a rug pull.
That's a red flag right away.
I mean, it could be incentivized and boosted. It doesn't matter. Like, I would really need to know the team. Like, for example, the Giza team, I know them quite well. So I trust the agent, even though they don't even use TEs, but they have like a session plus permission key system. I think it's still a trust issue. Like, just because something is built in crypto does definitely not mean it's a trustless system. And I think it's a big hindrance in agent adoption. So that's why more and more projects are now realizing like, hey, somehow people are not picking up my agent, even though I have no ill intent, but I can't kind of guarantee it to users. So that's where TEs come into play to provide this extra layer of guarantees to users. Hey, very likely he cannot drug me. I hope someone has checked the open source code. I do see it's audited. But yeah, there's lots of layers that go into it.
So I think, do you mind if I ask a question there, Prashant? I know you were asking the questions, but I'm interested to know what Marco thinks, because you're absolutely right, and I'd be interested to know what you think your average user should eventually look for to know that across all layers, it's all good. You know, it's not just security audits, it's not just open source software. It's almost like they need to be able to see the rubber stamp. Like the L2B stage model seems to work quite well. But yeah, interested to know what you guys think that might look like in the future.
Green check marks. Many green check marks. No, I'm joking. I mean, the best thing that you can do is kind of wait for reputable projects to have checked this specific agent or whatever it is. And once they start using it, you can kind of be sure.
Right.
But I agree, as a non-technical user, it's difficult as hell to actually verify if an agent is doing what it's supposed to be, how the funds are being controlled, etc. But I mean, same with any blockchain. Like, why should I trust Sapphire on Oasis? Why should I trust any Ethereum rollup to do what it's supposed to be? like we trust in the open source ethos and a community to be like, hey, someone has verified this at some point, and if there would be a problem, it would be flagged.
Yeah,
amazing, interesting. I think it's a wholesome food to eat that I would wrap up with. So if you are trying to use the tea just with one like side recipe or something like that, it's not going to work out. So tea is an entire wholesome food, and you have to learn it in and out. And that's where I have a lot of questions, honestly, around again. But I would love to pause here. But the whole idea, and I do have a very high hope for T down the line. The only concern for me, honestly, like I'll be very honest on this one, because we also aggregate a lot of systems around the globe, and the biggest challenge which we have faced is that there are a lot of Mac devices out there. There are all of these devices, they don't have inbuilt TEs. Now, if and I want them to have it. So the reason being, because if that happens, then imagine the decentralized security and decentralized systems can just capture the entire world without even like even, and then we have a massive unlock of all of these things which is coming up. So I think that's where I would love to wrap up, because that's where my concern basically around the T are going to be, is that see how rapidly other systems, hardware providers, and all of these guys are able to adopt and lower that configuration pipeline, so that any normal systems will have by default and can be like enabled for anyone, seeing the level of attacks which are happening also on laptops happening. But yeah, again, it just drills down, right? Who owns those keys? Who can change those fate of you? Like, it is Intel, India, or who? So with that, I'll pause here. I'll give back mic to again Prakash to do whatever he wants
Damn, to
but yeah,
finish this. But I got one thing: tea is mostly like marriage. So if you're really committed, then only use it. So and and coming back to what we have been doing, and specifically like this, we are at the 45-minute mark. So I'm just going to tell about tg.spheron.network. So people who have already been whitelisted, we have some missions for you, and let me open that pretty quickly. So for you to go ahead and do those missions, you just need to go get on to tg.spheron.network, and you have to finish these. And these are basically like utilizing the product itself. There are different steps on it. You can use Clippy, and you can use Console, and you can use Supernoders. It's already on there. You can go ahead and utilize it. And we have been running amazing campaigns around that, so you can also be part of that on Galaxy. So definitely looking up for the community to pull up on this and become part of this. And thank you so much, guys, for coming together, because this has been more of like, I got to know a lot about TEs today, like, because I had this set of understanding, like TE is a wall and around the server, and that's it. Like good, bad, like it was more of a very ape-based system in my head. But I'm right now, like, I grew on like to understand it more specifically, and even for the users as well. Like, this has been very amazing stream, honestly, around the education side for TEs especially. And thank you so much, Gavin, Marco, and Prashant, for being here and taking the time out. And best of luck for 10, OSS, and Spheron. So you get 1 minute pitch post this, so you can tell what you guys are working upon and what you guys are doing. Anything, something we should be excited for about that. And Gavin, Marco, and Prashant in the same respective order.
Okay, thanks. I wasn't prepared for the 1 minute pitch, but that's fine. I'll talk about 10 any day of the week. So, yeah, I guess for the audience, 10s, we're full into TEEs. We've been able to identify what we think is a fairly sweet vertical where you start combining AI with gaming. And if you go to House of 10 or houseof.10.xyz, you can see how we're using AI agents to play poker, which is on-chain poker. So something quite unique. You know, you can watch how AI against AI. You can see Gemini play poker against ChatGPT, against DeepSeek. So that's quite an interesting thing we're investigating, we're playing with, experimenting with. And yeah, we hope that's going to be an interesting future. That's not to say all the other, you know, standards encryption, use cases don't become relevant. Perp dexes are top of the list. Lots of talk about that the other week. Dark pools, that kind of stuff. So yeah, we're really excited about 10. If you want to start getting your hands dirty, the final chapter airdrop is live now. So go and check out 10's Discord or X for updates on final chapter, and start playing House of 10, Battleships, 10 Zen, all these fun things that you can do with 10 just to see how it works. Thanks, guys. Been an absolute pleasure being here.
Amazing. Thank you so much, Gavin.
That was a great spontaneous pitch. Come on. I mean, mine is Oasis has been around for a while. Those that kind of need on-chain privacy, they know where to find us. We are always happy to support projects that are interested in privacy, that have some cool use cases. In Sapphire or in Oasis, we call it smart privacy. So even if you just like a single part of your application needs to be private, you can build so the rest can be transparent. You can build your whole application on Base, Arbitrum, Solana, and if you want, and just keep a specific smart contract that requires a private state on our chain and utilize it. Since we are talking about the role of TEs and AI agents, I think TEs are a very interesting framework, or TE clouds. They provide some very unique value adds to these agents. If you feel like, hey, your agent is lacking in adoption, specifically if it is an agent that is supposed to hold user funds, let's talk. I think TEs plus decentralized key management can be a solution to adoption, because you can provide way more security and kind of verifiability to your users. Even if you do not care about security and decentralization and verifiability, you should know that we do. So we will handle all of that part, and you can just build your fun AI agent.
Amazing.
It's great to hear from both of you. Yeah, so from my side, we are building the world's largest community powered data center. And one day I believe that there should be, as I mentioned, is like we are looking forward for more TE systems to be get enabled, and we want them also to bring into the Spheron down the line. But for now, at like aggregating the devices, all the idle devices around the globe, and the whole concept of Spheron is to build the public good for compute. And the whole idea is that we want to enable researchers around the globe. We want to enable academics or any startup, anyone who's looking into the space, not go, and they should not stop their innovation just because of the lack. They should never. And that's where Spheron comes into the picture. It's purely decentralized. You can go log in, provide your compute. Somebody else will come and lease it out. Very simple, easy to use. All the toolkits are out there. And the other thing, you don't really need another marketplace into this. You can always focus Spheron, go and launch your own. We will never ask a question. And we will never raise a question, because we want decentralized systems to succeed. And that's what Spheron is standing for. Yeah, I'll stop here.
Amazing. 3 great pitches of 3 compute providers, and I think this is something what we stand for. And thank you so much for being here, guys. It was an amazing time. And up till next episode. Have a good one, folks.
Yeah.